Hello. Today, let me walk through Kth smallest integer in BST. Let's start stopwatch. Timer 20 minutes. Given the root over binary search tree BST and an integer k returns the k smallest value in the tree. A binary search tree has an important characteristic. So from the current node, uh, left subtree less and right subtree greater than the current node. This problem hopes that we get Kth smallest value. So we want to find ascending order list like this. 1, 2, 3, like this. How to get the list? We can traverse like this. Wait a minute. Hmm. Hmm. This tree is BST, not a BTS. So leftest node is smallest. Leftest node is smallest. Smallest. And rightest node is greater. Greatest. Hmm. This node is smallest node, for example, 1, and second smallest value is here, for example, 2, and so this node is left child from this node, and this node is parent from this node, and then next smallest value is here, and next is here, next is here, here, here. In this traversal, we first visit the left subtree. Then the parent node. So left parent and finally the right subtree. Generally, we call this is in-order traversal. In order. In order. Ow, sorry. In order traversal. In order traversal. In order traversal is type of DFS. Depth first search. It follows in order traverse, it follows the deep first strategy, but deep first strategy, but define define a specific order, left and parent and right. So in order traversal, which means left node, left parent, right order, this always gives value in sorted order. When you visit node in that order, the output becomes sorted ascending order. Mm. Let's jump into the code. Mm. Mm. First, we need to result array. Finally, we want to return Kth smallest value because result list is ascending list. And we want to use DFS, so recursive function, DFS. And we pass the node. And recursive function, we have to think about edge case. If not, node return none. And next is that's where the mainly point of in order traversal DFS. DFS node dot left. And we append node dot value and DFS node dot right. And finally, uh, we have to call DFS root. At first, no. If we try to implement in order traversal in Python, in a straightforward way, we end up writing like this. At first, I memorized this pattern, but the real question is, why does it have to be written this way, like this way? So let's walk through it step by step using a diagram to understand what's actually happening. One more time, I want to write more smart graph. Hmm, let's use blue. Hmm. うん。Okay, this is root node. うん。So first, うん、okay, one, two, three, four, five, no, five, six, seven, like this. Let's step by step reading this code. We call DFS root first. So first is this DFS4. And then this is not null. So next is DFS node left. So go to here. Current node is here, 2. And 2 we call DFS2. Then, but then this is not null. So next line is DFS node dot left. So go to here. Here we call DFS1. And then it's the same. This is not null, is not empty. So next is DFS node dot left, but this node's left child is null. So this is empty. So we return to here. Then DFS1 is not finished, have not finished yet. So we process here, let's append node.value. So then we append 1. And next line is DFS node.write, but write child is empty. So return. And DFS1 is finish. And return to DFS2. DFS2 is processing, have not finished yet. So let's append node.value. So 2, we append 2, and DFS node.write. So we check 3, DFS3, and but node left is null. So we append this. And right child is null. So we finish DFS3. So go back to DFS2, but DFS2 is finishing. So go back to DFS4. We append this. And DFS4's right node is 6. DFS node dot left is 5. So we check DFS 5. We append this. And we append this. We append this. This is, so this code is working. Do you understand? First, I'm not sure about this strategy. So, mm, this is complicated for me. But step by step, breakdown, it is simple. Okay, last, let me check time complexity and the space complexity. Time complexity is we use DFS and we traverse every node once. So big O, N, and space complexity is this recursive function stack. The maximum number of the stack is height. So big O, oh sorry. So big O height. Space complexity is this. Finally, this solution have to traverse every node of the tree and make the result list. But ideally, at the moment we find Kth smallest value, we want to stop traversal. So neat code, he walks through that way, but today is enough for me, enough to understanding in order traversal mechanism. So someday I'll try walk through. So let's check this answer. Okay, success accepted. Submit. Great job. Thank you for watching.